This is GCSE Physics Explained, and I'm going to tell you about force, mass and acceleration. So there's the equation for it. Force equals mass times by acceleration. Make sure you get the units right. Forces are measured in newtons, mass is measured in kilograms, and acceleration is meters per second squared. You don't want to have to write it out all the time, so we'll just say F equals M times by A. Now you can rearrange it into the different forms by using the magic triangle. So this is the way I like to think about it. To get the acceleration, you need to know how much force is acting on a certain mass of object. Okay, so here's some examples of what I mean. I've got this highly developed car over here, and I've just said it's got a mass of 10 kilograms. Right, if you're going to put a force of 20 newtons, so you're going to push that car with 20 newtons, to work out how much it's going to accelerate, just do acceleration is force over mass, so that's 20 newtons over 10 kilograms, and that'll come out as 2 newtons per kilogram. That's in newtons, that's in kilograms. Technically, newtons per kilogram would be fine, but we don't put acceleration in those units. We'll put them into meters per second squared. All right. Now, compare how much that object accelerates with this one. Now, if you're going to change one thing, you've got to keep everything else the same. So I've changed the mass to make it half as heavy. And so I've kept the force the same. All right, 20 newtons, just like before. So how much is this object going to accelerate? Right, always, by the way, do the equation and then pop your numbers in with the units and then the answer with the units. So it turns out here that this is 4 meters per second squared. So what you can see is you've put the same force on a smaller mass, and that's going to cause greater acceleration. Well, of course it is. You don't need me to tell you that. You've lived on the planet for long enough. If you've got one of your mates who's quite heavy and another mate who's not as heavy, then if you're going to push them with the same amount of force, then this little fella is going to accelerate more, isn't he? Now, if you make that observation, that'll get you a C grade, level 5. But if you're wanting higher than an old C, if you want like level 6 and above, then you need to make this observation. Check it out. If you half the mass, and it's got the same force on, you are going to double the acceleration. Okay? And that's what we call a positive relationship. And in fact, it's a directly proportional relationship, because as the mass halved, the acceleration doubled. Okie dokie. Right, let's have a look at these then. So this time I'm going to keep the mass the same, and we'll see the effect of doubling the force. And again, just say you're pushing your mate in a sledge. First of all, you just push him with a little force, and then you push the same lad with a bigger force, double the force. Well, you know that his acceleration is going to be bigger. But once again, let the examiner know that you understand that if you double the force on the same mass of object, you are going to double the acceleration. So look at that, acceleration, force over mass. So 40 newtons over a mass of 10 kilograms comes out as 4 meters a second squared. Whereas on this one, because you're only pushing it with half the amount of force, you're only getting half the amount of acceleration. Easier. So basically, bigger forces produce larger accelerations. And if you double the force, it's going to double the acceleration. So what about bigger objects? So bigger objects, more mass in other words, they need more force to produce the same acceleration as small objects. And the example that I use is, I say, imagine you've got this director and he wants an explosion to go off over here on the film set, and there's a little kid actor and there's a man, and the director wants both of these people to fly across the screen at the same time so they can both be in the same shot. You don't want the kid flying off first and then the lad, the big man travelling behind. All right. So I don't know if you know much about the movie sets, but basically what would happen is there'll be a machine over here, and you pull this hook out on a wire, and you attach it to a belt that's around this child actor. When you press this button here, it would pull the wire in. Okay, so you decide how much force this machine's gonna pull with, and this man, he would also have his own machine. Okay, so he'd be hooked up to a machine over here, and what they would need to know is what's the mass of the actors. So I've just simplified it. I've just said imagine the child is only 10 kilograms, and imagine the man is 20 kilograms. Right, so ask yourself this question: what's the relationship between these two? Well, the man is twice the mass of the child. So basically, if you're going to make it have the same acceleration, if he's got twice the mass, he's going to need twice the force. Okay, so just pull this little fella with 30 newtons and pull the old bloke with 60 newtons. All right, and there's the little mathematics to show you how to do it. All right, so the lad comes out as 3 meters a second, and there's the maths involved for the bloke, and that is again because he's got you need double the force because he's got double the mass, but it comes out as the same acceleration. All right, and that's how to do that. Right, and what I do in the lessons is I'll do like an acceleration experiment, and I get people to answer this question: what's the biggest acceleration you can create? So like I put one person into a go-kart, and I get one person to push. So what I need is I have a small person, and then I get a big person, and then I get someone who can push very strong, and someone who's a bit of a wimp. All right, so I don't tell him that though. Right, so and the question is what's the biggest acceleration you can create? Who are you going to put in the cart, and who are you going to get to push? So if you want a big acceleration, you just want someone who hasn't got much mass. So in that case, that was J. He was lighter, so 50 kilograms of mass. And I wanted to get a big, strong lad to push him. So that was Ewan. Spelled his name wrong, haven't I? So that was Ewan, which is, he could push with 600 newtons. So there's the little mathematics involved to get the acceleration, do the force over the mass, and you can work out how much it's going to accelerate. So I've just left that blank for now. You can do that now if you want. And then what's the smallest acceleration? So if you want the smallest acceleration, you want to make the cart really heavy. So put the big lad in the cart. All right, Lewis, he was heavy. Lots of mass. And just get someone who's not very strong to push him. Okay. So there we go. And then there's the mathematics involved. So if you want to work that out, and then I'll join you on the next slide. So there's the answers. All right, and you can see this one here, because I've just got someone who's got a little mass in the cart and someone who's pushing, he's very strong, or a big force. That comes out as 12 meters per second squared. That was his acceleration, so that's quite big. And then what's the smallest acceleration? Well, just get someone who can't push very hard, and someone who's very heavy, put them in the cart, and they didn't accelerate very much at all. All right, and that is how to take care of that. Thank you very much.